Catalyst is an enterprise class, adoptable, practical, distributed ledger, and distributed computing protocol. It's a new approach to this whole space, and I'll just spend a few minutes introducing what it is we've done that's a little bit different than what you've seen. I think everyone here knows the opportunities for distributed ledger and distributed computing to be able to take reconciliation costs to zero and the impact that will have on productivity and economic and costs, the ability to make illiquid assets liquid, the ability to track and trace assets, to be able to prove the provenance of everything from pharmaceuticals to food and produce. But the reality is that it's been too complex, it's been too insecure, it's been too expensive to actually take a lot of these projects and ideas into reality. So when we started Atlas City, we stepped back and said, if we're going to make this technology truly practical and truly adoptable in the real world for real business cases and real enterprises, what do we need to do? Well, we created a new approach, and we started from scratch. It's not forked from any existing protocol, as you know. Ethereum is a fork of Bitcoin. Hyperledger is a fork of Ethereum. Pretty much everyone has been starting from something that came before. We decided that that wasn't going to solve the problems that we needed to solve. And I'll just leave you before the demonstration. Why are we saying that you can potentially run a Twitter in a decentralized, distributed way? First question is that useful? I guess you have to ask whether you want to be in control of your personal data and your personal information, or are you okay letting other people control it? The full stack approach that Catalyst has developed, that we've developed for Catalyst, enables you to build Web3 kind of applications. And that's what we're going to demonstrate today, showing you how you can run a Twitter on Catalyst. The same will apply to be able to run email, a distributed email service. Would you like for your email not to be read by Google's AI and machine learning? Well, that's possible when you have a full stack approach. And you'll see, and James will talk about it in just a minute, how this works in practice. But in order to do that, you have to have a full stack, and that's what Catalyst is. Everything from the peer-to-peer networking layer to the end user application layer. So we have a wallet, of course. You can run applications, full applications in containers written in any language. You don't have to use a specialized programming language. If you know any of the 30+ .NET languages, C#, F#, Visual Basic, C++, you can write applications now to run in a distributed manner. Of course, we have consensus, but we've made innovations in the consensus layer. In order to keep it light and fast, you can run it on a single board. So you can run it on a Raspberry Pi. You can make an IoT device a node that can produce validations on the network and validate data at the edge. So we have innovations that are patent pending around that consensus methodology. But you can only make it fast and lean if you have a built-in distributed file storage system. Not external, but built in. So you don't have to wire in complex ways of bringing data from existing off-chain databases like DB2 or others. It's actually a distributed IPFS-like system that's built in. So the data is fractionalized, it's encrypted, and then it's distributed. When it's needed, it's reconstituted by the network. This is a much safer way to store data and a much easier way to share data. It's GDPR compliant. You don't have to deal with the complexities of having lots of off-chain databases in order to make Catalyst work. So this is what you need. In order to run a decentralized Twitter, you need the full stack approach to make it simple and straightforward. And James, who, if you were here, anyone here for the previous developer den? So maybe you know a little bit, but James is our head of engineering. And he's been working on this protocol for the last 16 months and taking this new approach to build the whole stack. So with that, I'll turn it over to you, James.
So, thank you, Chris. Stole a bit of my introduction, but it's okay. So yeah, we're talking about the full stack approach, more specifically the full stack Web3 solution. So Web3 is a new movement, a new movement born out of a broken web that we currently have. The rise in popularity in consensus protocols, where users are now demanding more privacy, more security, and more control over their data. But how did we get to Web3? So here's kind of a bit of a history of the previous generations of the web. Web 1.0 is what we call the information economy. It's more of a one-to-many online platform where few businesses and organizations held a one-way dialogue with people over the web. They could pass on information in a variety of ways, but the interaction was limited. Users of Web 1 were just essentially consumers of that data and of the web. Web 1 predominantly funded itself through unsophisticated ad tech like banner ads and pop-ups. Towards the end of the Web 1.0 era, users got sick of this type of advertising to the extent where in 2003, lawsuits were actually filed against web companies trying to stop people from pushing ads onto the users. The judge's response was, alas, as web users must endure pop-ups. Around 2000, we started to transition into what we call the Web 2.0, or the platform economy. The main concept of the Web 2.0 was that there's a many-to-many user-curated content, or the social media. Websites became known as platforms, in which themselves users just curated all the content. The platforms themselves didn't really do anything, and uploaded it and shared it amongst their peers. These platforms are all predominantly offered underneath the guise of free-to-use platforms where users don't pay a monetary value to use the platform, nor did they fund their operations through unsophisticated, untargeted ads. YouTube and Facebook didn't start showing ads until 2007, but instead we gave up something even more important, our data, our privacy, and in a lot of cases our freedoms. In doing so, the champions of Web 2.0 started the process of commodification of user data on their platforms. Now, here's a quote. This is actually taken from the satire site The Onion, so this is not actually the CIA guy saying this. But it's quite funny because it's so true. Everyone's uploading all this personal information, all this personal data to these central services. But what was actually more funny about this was this piece of content was produced in 2011, 2 years before the Snowden revelations, but we'll get to that in a bit. So I want to talk about these Web 2.0 platforms. Every time you interact with them, a copy of the data is sent to a centralized service, stored in a walled garden of servers and in the cloud. But can we trust these people and these institutions to store this data and manage it sensibly, internally or externally, prevent it from being used in bad ways or from corruption? So for example, let's look at the US retail giant Target. Target effectively data mined its way into the womb of every female customer. In 2012, New York Times journalist Charles Duhigg spoke with Target data analysts, revealed that every shopper within Target was assigned a unique tracking ID tied to their credit cards, name, email addresses, and this became a bucket of history of everything that users bought across their web assets and then in-store as well. Analyzing these data sets, useful patterns started to emerge. For example, lotions. Lots of people buy lotions, but analysts found that women who were on baby registries were buying lotions in large quantities around the beginning of their second trimester. Another analyst noticed that sometime in the first 20 weeks, pregnant women started loading up on supplements like calcium, magnesium, and zinc. Many people buy this stuff, but when they start suddenly buying lots of this, in addition to other products like hand sanitizers, washcloths, it signals that they're essentially pregnant. what they actually did was start to give people a prediction score on how pregnant they were, and they actually used that data to then start sending coupons to target customers at specific stages of their pregnancies for different products. So what so take for example, a shopper. She's 23, in March, bought cocoa butter, a large purse, big enough to be a diaper bag, supplements, and a rug. Target analysts would say there's about an 87% chance that this woman was pregnant, and her due date was in August. And this wasn't actually, it turns out this wasn't actually an anecdote. This has actually turned out to be fact, that there was a teenage girl who got pregnant and was buying all this stuff on Target and started sending her mails for coupons, and her dad went to Target and started demanding an apology, and it turns out that it was actually true. And that's creepy enough that these Web 2.0 platforms can collect so much data to actually know before some of your family some of the most intimate moments. But can we really say that this data collection can change our freedoms or our free will? Facebook is probably the biggest social experiment lab on the planet, and they've been unconsensually experimenting on users of the Facebook platform since its inception, pretty much. In 2010, they did a study. There was a midterm election, and Facebook planted a I voted button on the top of each user's newsfeed, so people could say when they'd been voting. You could see the names and friends of people who had clicked the button, and researchers found that this kind of social diffusion of information actually influenced people into actually going and voting. Which seems benign enough, but what if actually Facebook manipulated how that data was shared across different users? You could actually argue that they could manipulate the outcome of democratic elections. Same with social influence or not. Another study that they did was that they would show fake endorsements from friends to see if you'd actually end up buying more products. The spread of emotion. This was another study that they did that actually looked at how people would react looking at different data feeds and different content updates from users on the network. This was a study done on 150 million users without actually being authorized to do so by the end users themselves. The next one's quite interesting. It's quite scary. The emotional contagion, a study that they did, where Facebook actually manipulated all the data feeds from users, well, not all, sorry, of all 690,000 users. They actually manipulated what data was actually shown publicly, showing some people more positive ones, showing people some more negative ones, to see how that affected the users' moods. Another study that they did, self-censorship on 4 million users. They actually tracked bits of content before you'd even posted it to the social network. So by just typing stuff into a box, they were collecting all that data to see actually how many people would censor their own information. So you would say that it wouldn't get too much worse for these kind of platforms with all this kind of data collection and all this kind of creepy stuff they're doing in Web 2.0, but it does. In 2013, CIA and NSA security contractor Edward Snowden actually leaked highly classified documents pertaining to the global surveillance program, which in my opinion was one of the most damaging revelations of a generation. The leak detailed one of the most widespread domestic and international espionage programs, something that conspiracy nuts had been saying for years before, but no one was listening to them. The leaks described telephone tapping in cooperation with telephone companies and tapping of internet infrastructure. It promoted the weak encryption in technologies, as well as paying bribes to people like RSA to put backdoors in encryption products. It demanded backdoors into actually some of the actual critical infrastructure and servers of some of these big Web 2.0 platforms, such as Apple, YouTube, Facebook. Those who didn't comply, they simply just tapped the data center traffic, scooping up anything that they could. They had a tool called X-Keystore that allowed intelligence analysts to literally search anything that people had been doing over the internet. In the case of Yahoo, company execs actually installed direct access to all mail servers for the spy program, without even informing some of their chief security officers. The spy program even extended to intercepting mail, hardware deliveries of laptops, computers, and servers to install malware on them before continuing their journey to customers. The New York Times report revealed NSA and British authorities teamed up together to actually find out how many pigs you killed on Angry Bird for some reason. I guess they had the interns in there, so they had to give them a little bit of an analyst project to do. But the point of all this is like the web's broken as we know it today, and it's really unfit for its purpose. And it's really to do with this paradigm of a client-server architecture. We've had the web for almost 30 years, but this paradigm has never really changed. No one's ever really thought of thinking, hey, wait a minute, people are putting malware on servers, people are breaking the internet, they're tapping phone cables and transatlantic fiber optics and all this kind of stuff, but yet we still think that this is the best option to really do something. The client-server web has got centralized data management, centralized around cloud, centralized around servers. These institutions led to essentially data monarchies where these people like Facebook had so much information on you that they can just play with you and toy with you. But the current web could also be described as being built on stateless protocols. They don't have any native mechanism to authoritatively say who owns what and who has permissions to do what. Stateless protocols like the web can only manage to transfer information where sender and receiver of that information are unaware of the state of each other. The lack of state is based on the underlying protocols that underpin this web and this client web architecture, such as the data transmission protocol, TCP, as well as subsequent protocols built on top of it, such as HTTP or SMTP. These protocols are used in just only the transmission of data. But can we fix it? Hopefully. This is the whole idea of Web3, that we're trying to really think and re-architect that back-end architecture, what underpins the internet, rethink these paradigms that are no longer fit for purpose, remove these unelected data monarchs who collect and abuse all this data for their own corporate and political greed. The Web3 movement has really become a war cry for a new and a better web. The Web3 movement is different from the previous generations of web. Web3 isn't just about offering information or just giving people a platform to do as they want. It's about everyone being their own platform and everyone having sovereignty over their own platform, their own data, and their own identity. It's about the power, and it's about who has control over that power and the technologies and the services you use. It's about the users of the web having a real choice in how they interact with the web and the users of it. And it gives the users of Web3 the power back. And this really has all come around from the rise of the consensus-based protocols like blockchains, where they introduce this idea of each participant in a network can hold value and transfer value via a native state layer, without the need to use these centralized client-server architectures, removing the intermediaries. Consensus protocols, and blockchains really do remember everything that you've done and provide a real source of truth. In comparison to the Web 2.0 platform economy, where users are only given the choice of using a site for free and giving up your data to these institutions as they please, imagine if you had a Web3 architecture which looks something similar to like this, where you no longer are just a client interacting with a server from some one organization. Every user on that network is a node, and it has the ability to publish content, consume content, but also interface with that state layer and actually provide a source of truth underneath. In the Web3, we do away with this technical debt that we've inherited for the last 30 years and move this idea of this peer-to-peer network. But it doesn't mean to say that Web 2 doesn't completely work. It doesn't mean that Web 2 and Web 3 can't coexist. It's a real transition. So how does building a Web 3 website look like? This is a very simple Web 2 architecture. You've got your client, you've got the internet, you've got your web server, you've got your back-end app server, and you've got your database server. Yeah, so every time you want to interact with that, you have to go over this, over the web, and interface with this like this. But this, this centralized service in the back end, once you've sent or received or done anything over this kind of architecture, any sort of data you've posted these services, you've essentially given up any right to control. Again, this is kind of what an actual real Web3 distributed web would look like. Every single person has, with a Catalyst system, a back-end database. They have an application server with a distributed compute, and that underpinning state layer from the KVM. So for people who were here before, this kind of diagram will make a little bit more sense. We talked in the last talk about the modular nature of Catalyst and how you can build different distributions and flavors of the nodes and interact on a peer-to-peer network. So we've been kind of doing a simple POC on this, really, which is just a very simple version of Twitter running on Catalyst. As you can see, we use all the existing blockchain modules that we do on our standard node. But what we actually do on the top layer is we provide a Twitter module. We've been working on the Twitter module. And what that does is that actually stores all users' tweets and data on the ledger, on the DFS. So that acts as that single source of truth. That is now on your node, and it's not put on a central service, and it can't be manipulated by Zuckerberg into changing your emotions, because no one owns it apart from yourself. So this is actually Twitter running on Catalyst, and it looks exactly the same as any other website. This is actually running on our node software. We're going to be open sourcing this in a few weeks' time. It just looks like any other website. It's just it's got a standard UI, but this has all been served by a node. So every single node has its own UI, can interface itself. It doesn't have to go to any centralized services. And like any other blockchain protocol or any other consensus-based protocol, when you want to make a transaction and actually get it appended to the ledger, this is exactly how a Twitter on Catalyst would look like. So if I wanted to send money to someone, we would broadcast that to multiple different nodes and have a consensus cycle on it. And it's the same with Catalyst on Twitter. You can, if you want to get something into the ledger, you can write a tweet. Right there. And this is really the same concept of actually broadcasting a transaction to the rest of the network. So, fingers crossed this actually works, but upon actually sending the tweet, what's actually happened now is it's been broadcasted to the network. A ledger cycle has been completed, and as you can see now, this has actually started to come into all the other nodes. Oh. Never do a live demo. Yeah. I'm not sure. Sorry, I think the internet in this place is a little bit slow. We're not getting the feeds as quickly as I'd like them. So, like I said, what's actually happening here is when wanting to produce a tweet in a standard Web 2.0 paradigm, what you do is you would send that to a client-server model, and that data is then stored. But what we're actually doing in the Web 3 model on Catalyst is we're leveraging all of this stuff we've been building, where by making a tweet, we're broadcasting it to all the other nodes in the network. They're validating that as being a true transaction. Only you can send a transaction. There's no concepts of logging in. There's no database servers with emails. I mean, even Twitter's not infallible to being hacked. Jack Dorsey's account got hacked himself. In this case, you would never be able to do that because only the person with a key would be able to actually send a message from Charlie or send a message from Alice. And once it's actually been broadcasted, once it's gone through the consensus cycle, and we've agreed that this is factual, it actually gets appended to the ledger. And what we're actually seeing on the timeline is a historical view of the ledger where people have broadcasted transactions and it's actually been appended onto there. This isn't actually just running on any cloud. This whole website is actually hosted on the DFS. We've also been working on a kind of a gateway that allows you to essentially have a gateway into the entire web. So any website that is actually hosted on DFS, you can just go to your own local node and pull up that website and interact with it like any other website you already know. And yeah, I mean, it just kind of looks like a normal website. But this is all just running on Catalyst, and feel free to go and get the IPs and interact with it. We're going to leave it up for the rest of the day. And then we will be open sourcing this code in a few weeks' time, just for people to play around with. This is just another example of the kind of things that we've been doing. And some guys are actually tweeting these two people over there on the laptops. They're the guys that are actually sending the transactions at the moment. Thanks, guys. Yeah. And that is the end of the demonstration.